Good morning, friends. This is Durga from ITversity. As you guys might be aware, this is a live session for my paid audience, and this is just a backup. This is Durga from ITversity. This is just a backup for them, and hence I might not be able to answer your questions. So bear with me, but you can follow and learn for free. That being said, at this time we are talking about data frame APIs in Spark, and as part of today's session, I will be talking about windowing our analytics functions. And the most of the demos will be done using our labs, which is available at labs.itversity.com. You can go to our labs and then go to products. And you can sign up to the Big Data Developer Lab for one of these plans. Okay, and then you will get access to a 10-node cluster and you can practice on that. Also, while learning, if you have any questions, you can sign up for our forums. It's a 6,000 plus community forum, and it's pretty active, and most of your questions will get answered. Also, if you want to sign up for our courses, we have our own LMS, kaizen.itversity.com. Still, it's in progress, and there are few courses available. You can sign up for these courses. Otherwise, you can stay tuned and sign up whenever the course you are looking for is available. That being said, now let me get into the session, and then we will take it from there. I have to launch the session so that my live audience can join, and then we will take it from there. Okay, so the people are being joined, so bear with me. So it will take some time, a couple of minutes probably. Once the live audience, all the live audience join, we will start the session. Meanwhile, let me explain where we stand from past few classes. So I'm opening the IntelliJ, using which I have started developing an application yesterday. And then I will quickly recap whatever is covered and what we are going to cover today's session as part of today's session. So this is what we have done yesterday. We have understood data frame operations, and then we started writing this program where we actually read the data from orders and order items, and we provided solution for the problem, which is nothing but getting daily revenue for each product. Okay, so we have explore join operation, group by operation, and then aggregations using that group by, and also we have seen order by, and we have used all those things, and we finally saved the daily product revenue in ascending order by date, and then descending order by revenue as part of the file in the JSON format. And if I open that, so this is my directory. It is get daily product revenue DS. So I have to search for G. these are the JSON files which stores the output. So let me open one of them and let us see the output. So for each date, we got the revenue, product revenue in descending order. Okay. So now, as part of today's session, we'll be doing predominantly two things. One, if you really think about development lifecycle of a project, we should not be hard coding the input path, output path, etc. like this, because when we push it to production, the location might be significantly different, and we will not be able to refactor the code by changing these hard-coded literals and push it to production. Then you will be pushing untested code. For all practical purposes, we have to externalize these properties, such as input directory, output directory, and probably this one, which is master, because Spark can be run in local mode in development, but in production we have to use Yarn or Mesos, and hence, depending upon the environment, we have to determine which mode it should run. For that reason, even this master needs to be externalized. So we will actually look into that aspect by improvising this program so that we actually externalize the properties. And also, if I want to get ranking done, so in this case, if you look at the data is in ascending order by date and then descending order by daily product revenue. But quite often, I might want to see top 5 products every day by revenue, or top 10 products by top 10 products by revenue every day, so on and so forth. It is kind of ranking within each group. For that purpose, we have to understand a advanced set of functions that are categorized as windowing or analytics functions. In some database world, it is called as analytics functions. In some database world, it is called as windowing functions. So we will explore those things and try to get by group ranking as well. So first we'll start with analytics or windowing functions using data frame operations, and then we will actually improvise the program. For that, I'm actually launching Spark Shell here. Okay. Once the Spark Shell is launched, I can copy code from here till here. Now, daily product revenue is data frame, which contains date, product ID, and product revenue in ascending order by date and in descending order by revenue, right? So this is the data frame. Now, if I want to get ranking done, I want to give ranking within each date based upon product revenue in descending order. So in traditional SQL, if you are familiar with, we use something called select rank over partition by, and then so on and so forth. So we use multiple clauses like over, partition by, order by, etc. Okay. So these are called as analytics functions or windowing functions, and we have to use this to actually establish ranks within each group. Or there are other scenarios also. And the common use case is, let's say I want to compute average revenue along with the daily product revenue. I want to compute average revenue for each day, and I want to see which product is generating better than average revenue and which products are actually getting poorer than average revenue. So all these kinds of use cases can be implemented using analytics or windowing functions. Okay, so analytics functions or windowing functions are categorized into 3. One is aggregate functions. Second one is ranking functions. These are quite obvious. So aggregate functions are nothing but sum, average, min, max, etc. And ranking functions are nothing but rank, dense rank, row number, etc. So these are the ranking functions which we typically use. On top of these two things, there is also something called windowing functions, and they are nothing but lead, lag, so on and so forth. So if you want to build some time series related information, so if you want to compare the current value, current records field value with the next records field value based upon certain criteria, then we use these windowing functions such as lead and lag. Okay, so for today's discussion, I will be focused on aggregate functions and ranking functions. Windowing functions we will try to see some other time if time permits. Otherwise, you can actually explore by yourself whenever it is relevant to you. Okay. So one common thing with respect to all these different types of analytics or windowing functions such as aggregations, ranking, and windowing functions such as lead and lag are they start with a function. Okay. And then they start have war clause. If you want to write in select query, it will look like this. It will be like select function over, and then bracket, and then partition by the grouping key field. Okay, so we typically have to identify what is the grouping key field, and then if it is aggregation, we just need partition by clause. We don't need to use others. But if it is ranking, within each group, we have to determine on which field the ranking should be done and whether it should be ascending or descending. And then we have to use order by clause for sorting key field. Okay, and it can be ascending or descending. By default, it is ascending. You can also sort the data in descending order. And then you will write the query. So for example, if this is a table with the 3 fields, so let's, sorry, for the typo in from clause, that's fine. I'm just giving a template for the query. As part of the from clause, we will give the table name, daily product revenue, and you will get the ranking or aggregation, whatever it is required. Now, if I have to write this using data frame operations, not SQL syntax, but data frame APIs. Data frames provide you certain APIs which you need to understand, and you can come up with logic. One thing you need to understand is typically these aggregation or analytics functions are used as part of select clause. Okay, which means we have to take the data frame name, which is nothing but daily product revenue in this case, and then as part of the select clause, we have to define this entire thing. Okay, so we'll come back to this at a later point in time. For now, first let us build this, and then we will pass it to the select clause. Okay, how to build this? First, you need to import org.apache.spark.sql. I think expressions, and then dot and hit tab. You can see there are multiple classes out of these things. The most important classes are window and window spec. Okay, so we need to build window spec object, and to build window spec object, there is a helper method in window which we need to use. So we have to just import these things. Okay, and then first we'll build the spec equal to window dot, and if you look at window, you got these APIs such as partition by, order by, etc. Okay, so to actually specify partition by, we can say partition by here. So let us define a problem statement before getting further. So first, let me compute the average revenue for each day. That is in my problem statement. So taking daily product revenue, I want to compute average revenue for each day. So whenever you see this keyword like for or per, that will actually determine our grouping key or partition by key. In this case, date is the one which gives us the day, and hence the grouping key is date. Okay, so what I can do, I can say spec equal to window. Here you can use partition by, and you can give either column type or string type, and you can give whatever name you want in the form of string or column. But you need to keep in mind that you have to use appropriate field names for your data frame. So first we need to, even though it takes anything, when we run at runtime, it might fail if the column names are not correct. And hence, first we have to get the schema of the data frame on which we are trying to build this. So I can say daily product revenue, print schema. We have these three fields: order date, order item product ID, and daily product revenue. Okay, and then I can build the spec equal to window dot partition by and order date. So we got the partition by clause, partition by order date in native SQL style or SQL style. Now we have to add over to it, right? So if you look at spec now, spec dot and hit tab. If you want, you can apply order by. Now what you can do is, if you look at the syntax of select, let me take daily product revenue dot select, and if you look at the syntax of select, select either takes a varying number of string, in which case we have to pass exact column names, or it takes column type. So when we pass column type, that means we can invoke a function as well. Okay, so if you look at select and if you hit a tab, okay, I cannot display everything. What you can do is, if you go to org dot apache dot spark dot sql dot functions and dot and then hit tab. Okay, so you have functions like whatever functions we have seen day before yesterday, like string manipulation and date manipulation functions. And the third category, if you can recollect from Databricks syllabus, is aggregate functions. What are those aggregate functions? Count, which we have seen yesterday, and then min, max. Also on top of these things, we have average and sum, etc. So all these are functions which we can use to aggregate the data. Okay, so now if I go back to daily product revenue dot select, in this case we are talking about average, right? So I can say average. Okay, and we have to give some field name. Let's say the field name for computing average is nothing but daily product revenue. Okay, and once you use average function, if you want to get the list of functions exposed on top of average, by hitting tab, by saying dot, there is a function called over. Okay, so we can use over, and then to the over we can pass the spec which we have built earlier. Okay, so I can pass the spec, and then we should be able to get the data. Okay, so let me show you here. You can see it is actually resolving into average daily product revenue or partition by order date, and we haven't specified anything ascending or descending, or there are other valid frames also if you want to develop windowing functions, and that's why it is showing like this. And you can actually say dot show, and you can see the average revenue. It is using 200 threads unnecessarily. So what I can do, I can actually say spark dot conf dot set spark dot sql dot shuffle partitions, and then 2. Now it will be faster. Okay, and if you want to get everything, you can just say means all the other fields along with this average, we can just say with column. Okay, and the first one will be alias, which is nothing but average revenue, and the second one will be the actual API, and hit enter. We have one extra. And now you see, we got not only the daily product revenue, we also got average revenue for each day. Means for each product, how much, what is the average revenue on each day, which is nothing but 2026. Now, if I want to compare, or if I want to get all those products which generated less than average revenue, I can just say daily product revenue less than average revenue, and we are good to go. So we can just apply where clause and we can take it from there. So let us go back to the spec once again. So spec contains the partition by clause itself. Let me go back the complete logic which you have applied to this spec object, and then we can actually build function. So in this case, let's say average revenue. Let's say this is a column type. So using spec, we will actually build the column type. So in this case, we are trying to get average revenue. So I can say avg, and this avg is from mock.apache.spark.sql.functions. And as part of this, we can pass any column name. So in this case, the column name is nothing but daily product revenue. Again, this is part of our data frame. Daily product revenue is one of the fields in our data frame. And then we can actually specify over, okay? And for over, we can actually pass spec like this. So we pre-build the column, and we named it as average revenue. So as part of this with column, instead of writing the complex logic, now we can actually use the variable name. This is a bit more meaningful or readable, and then we will be able to get the data. Both are same. In this case, I have created a variable which have the logic to apply the aggregate analytic function to get the average revenues for each date. And here you need to remember that when you specify, when you define the spec by using window.partition by clause or whatever functions you want, you need to pass correct column name, even though syntactically it will not enforce at the time. If you give incorrect column names, it will throw errors here. Okay, and then using this spec, I have build column type using average function and passing the spec to over. We can also write the same query without creating these multiple intermediate objects directly here. So I just have to say average call daily product revenue and then over. Here I have to say window dot partition by order date. That's it. Okay, there seems to be some issue with this. Okay, it's order hyphen. I have given not order underscore. That's why it has thrown exception. Okay, so instead of writing like this, probably it might be a good idea to create a variable out of this the way I have done, and then you can pass to get the average revenue. Okay, similarly, if you want to give rank, so I'm taking daily product revenue dot print schema to get the schema details. So we have order date, order item, product ID, and daily product revenue. Now let us define a problem statement. Get rank for each product based on revenue for each day. Okay, so here within group defined by partition key date, I want to get rank assigned based on product revenue. So what we are supposed to do, typically we will sort the data in descending order, and we will give the rank 1 for the topmost product. And hence we not only have to partition by order date, we also have to sort the data in descending order by daily product revenue. So the spec will look like this: spec equal to window dot, okay, just give me a moment. Okay, everything is good. So there was a small glitch in YouTube live session. That's why I have to pause it for a moment. Now it is back to normal. So spec equal to window dot, and I have to define partition by clause. In this case, partition by is nothing but order date. And then after partition by, in case of ranking, we have to sort the data. And if you look at the APS, there is an API called order by, which is exposed to the spec. So I can say order by. Okay. And if you look at the order by, either you can pass it as column type or string type. With string type, you cannot manipulate the field. You have to pass the exact field. But if you want to sort the data in descending order, or if you want to concatenate something while sorting the data, then you have to use column type. Okay, so in this case, I'll be using call type daily product revenue, because we have to sort the data in descending order. Only when you define it as call type, DESC is exposed to you. So you can use DES and then close it. Now the spec is defined. I can say daily product revenue dot with column, because I want to get all the other fields along with this. And I can say field name or alias name, RNK, and then I have to invoke rank function, rank dot over spec. Okay, and then hit enter. Now you can say show, and you will get the rank for each product based on the revenue within each day. Now I want to get only top 5 products. Then after applying rank, I can say where. Okay, and then I can say RNK, because that is the alias name, less than or equal to 5. And to make sure data is sorted, I can say order by. Okay, dollar order date, comma, dollar rank. Okay, and then I can say show. Now you got top 5 products for each day. Okay. Also, it supports dense rank. I hope you are familiar with the difference between rank and dense rank. In case of dense rank, if there are 2 guys who have the same rank, then the next rank will skip 1 number. So in this case, let's say both of these have 5099. So both of them will get, I think 3 and 3 or 2 and 2. I do not remember. But the next guy will get 4. He will not get 3, even if there is a, yeah, I think first guy will get 1, and the second guys will get 2 and 2, and the next guy, instead of getting 3, he will get 4. Okay, but if you say regular rank, the first guy will get 1, second and third guys will get 2 and 2, and the fourth guy will get 3, and so on and so forth. So one of them rank skips the numbers ranks in between if there are multiple rank holders with the same rank, and the other one does not skip. That's the difference between rank and dense rank. You can also assign row numbers based upon certain criteria. So even if there are duplicates, if you just want to give incremented number such as 1, 2, 3, 4, 5, so on and so forth, then you can also use a function called row number. So these are the 3 most common functions that are used for ranking. And you can leverage those things to get by key ranking. Okay, so this is brief overview about aggregations and ranking using analytics functions that are supported using data frame operations. Now we have to apply this as part of our program. So I am developing one more program here from the scratch. Okay, so that you understand the steps, development lifecycle steps, and we will take it from there. Okay, so in this case, I am saying new Scala class. I am defining it as object, and I am saying get top and daily products. So this is my program name, and I am saying DF because I'll be showcasing this with the traditional SQL also as part of next class, and hence I'm defining df here, and then say okay. Okay, before developing the program as part of the build.sbt, you need to make sure that Spark SQL is added as dependency. Okay, only then you should start writing the program. As it is already added earlier, now we can go to this program, and here I am defining main function. Okay, and then first thing what you have to do is you have to create Spark object of type Spark session. Okay, so you can hit enter. Sorry, val Spark equal to Spark session. You can see that it is automatically imported for you. So Spark session dot builder, and then we have to set master. For now I'm hard coding. I will improvise on this and externalize the properties at a later point in time, and then dot, and then app name, get top n. I will be passing it an argument, and I will customize this a bit later. For now I will just give this generic name, get top n products per day, and then get or create. So automatically Spark session object will create a Spark context for you, and on top of it, it will expose all the SQL based APIs or data frame based APIs for you to read the data, to process the data, etc. Okay, so before getting further, first thing what I will be doing is I'll be importing spark.implicits dot underscore. It will expose APIs such as filter, where, join, etc. Unless you specify this, you will not be able to use those APIs. As of now, it is none of them are used. That's why it is grayed out. But once we start using appropriate APIs, it will be used automatically for you. On top of these things, before actually importing, I want to get Spark context from the Spark, and then I want to set log level to error so that we don't see unnecessary logs once the context is created. Okay, and also to use a limited number of resources rather than using 200 threads, I am trying to get the runtime properties for the Spark session using spark.conf, and then I am setting spark.sql.shuffle.partitions, and I'll be setting it to 2. Okay, now we can actually read the data. So I'm creating a variable called input base directory equal to, for now I am hard coding once again, but afterwards I will externalize the properties, slash users itversity research data retail db json. So this is my input base directory, and then for this problem statement of getting top and daily products, we need orders and order items. So I am reading orders from JSON by saying orders equal to spark.read.json input base directory. Let me do this. Let me close this. Yeah, input base directory plus orders. Okay, and then I want to read order items also. Okay, now once we get orders and order items read, we can get the schema by saying orders.print schema, order items.print schema, and see the field names. And also we can use orders.sort just to preview the data, but don't add those lines of codes to print schema or to preview the data as part of your main program. If you add, just validate and delete those things. Don't keep them permanently. Okay, now I can compute daily product revenue I'm reiterating all the functions which I have used yesterday. So in our problem statement, we need to get only those orders which are either in complete or closed state. So I can say orders where, okay, and I'm using native SQL style, SQL style syntax, not native data frame operation syntax. If you want to use native data frame operation syntax, you have to say dollar order status, and then you have to use is in, and then you have to pass the literals in circular brackets like this to compare with complete and closed orders. In case of native syntax, you can just remove this dollar. You have to pass everything as string. In SQL, we typically use single quotes to represent strings, and hence we have to use the same thing here. Okay, and then we have to close this. Okay, and this is the SQL style syntax to compare order status with complete or closed. Once this is done, I can join with order items, and then I can say order ID from orders equal to order item order ID. Okay, once it is joined, now I can say group by. Okay, and I can give the field names on which the data needs to be grouped. One is order date, second one is order item product ID, and then we can either use sum, or you can actually use ag and pass sum to it. And here using ag is better, so that we can give alias to our aggregated field. Okay, so I can say ag of sum of order item subtotal. Okay, and then I can give alias as daily product revenue. Now if you see, it is showing in red because it cannot resolve the symbol. To fix this, I have to import arg.apache.spark.sql.functions._. Okay, it will expose all the functions for you. As we get daily product revenue, now we can use this, and we can actually apply the analytics functions on top of it. So we should not use analytics function here. So if you use analytics function here, you will get a lot more records. So let me demonstrate what I'm talking about. So let's say we got join like this. Okay, so val orders join equal to, okay, and let's say we run this, and then you say order join dot show. So some people might feel that why can't we use analytics function such as sum and average here itself. So the if you use analytics function here itself, then what will happen is you will find these many records. Let me show you. It actually returns 75,408. So now let me use this orders.join, okay, and select the fields we are looking for. So after join, we are only interested in order date, right? And then order item product ID and order item subtotal. We don't need anything else, and we haven't aggregated here. We just join, and we got these three fields. After this, I can specify with column, okay, and get daily product revenue, and then say sum of order item subtotal. So here I am specifying as sum as analytics function rather than simple group by function, the way I have written in the main program. So syntax is a bit different. Okay, significantly different. Here I'm using simple group by and then aggregating based on the group by field, whereas here I am trying to use analytics function to get daily product revenue. So once you get this, you can say dot over. Okay, and as part of the over clause, I can say window dot spec. Okay, and then I can say partition by order date, comma, order item, product ID. There might be some typos. I will see. So this bracket is closing bracket for partition by. This is for spec. This is for over, and this is for with column. And let me hit enter. Okay, I know. So let me recollect the syntax real quick, or let me actually define a spec here. So val spec equal to window dot. Yeah, I understand now. It is not window dot spec. It is window dot partition by. So I just have to go here and then take this and remove the spec here. And remove one of the circular brackets. Now it is working fine. So let me first get daily daily product revenue. Okay, equal to, let me make it a bit readable. Okay. Okay, so now we got the column type, which have the specification and all those things. And now as part of the with column clause, I can actually say daily product revenue to make it a bit more readable. Okay, and then dot, and then we can say show. Now you see, we got the revenue as expected. Okay, 1 minute, there is some issue here. Yeah, it is correct. We got the revenue as expected for 24. We got 399.96 as revenue for date 2013 July 25th. For 226, we got 599.99. For 364, we got 3359.4399. But the side effect of using analytics functions rather than regular group by and then adding, you got all the field names also here. So the number of records will be much, much higher. So now if I say count on this, you will still get 75,408. Okay. However, there is a where we can get the distinct and then get the results, but it's a bit convoluted way. Again, if this approach is worse in performance compared to this, you can compare and contrast and you can decide. But typically, it is better to write like this because this is traditional approach of grouping by multiple columns and then perform aggregations. And then on top of this, we can build the logic to give ranking or average revenue, etc. Okay, so you can use either approach, but I prefer this. This is a bit more cleaner, and it gives us order date, order item, product ID, unique ones, and then aggregated daily revenue for the combination of unique date and product ID. Okay, so let me copy paste this. I'm sorry. What happened? Why it is? Yeah, now it is fine. Now if I say daily product revenue dot count, it will give lot fewer records. There are only 9,120. We can get the same thing here also. So using the analytics function approach by saying with column, you just have to select the fields you are looking for. So after aggregation, we don't need um, uh, order item subtotal, right? We only need order date, order item product ID, and daily product revenue. So I can say order date, order item, or I can actually say drop. Okay, from this data frame, I can drop order item subtotal, and then you can say distinct, and then count. Okay, I know what is the problem. I have to go back here, run this. Okay, because I am using the same variable name for this, and then the copy pasted code, it is causing some issue. Now I can say order join dot select, get all the fields we are looking for, then use with column to get the daily product revenue. But there will be 70,000 plus records because you have a unique order item subtotal for each entry. Okay, and hence we can drop order item subtotal because we don't need any more. Once we remove order item subtotal on these results, if we say distinct, all these records with 365, there will be only one. Okay, but if you have order item subtotal and then apply distinct, again there will be a lot of duplicates. Okay, so eliminate order item subtotal from that which is not required, and then we can apply distinct, and then we can get count, and it is same as whatever we got with group by logic. Okay, if you want to use this approach, you can actually compute daily product revenue and also rank within the same results in some cases, but still it is a bit convoluted, and hence I use more straightforward approach here, and I will get into analytics functions only when it is absolutely necessary. For getting ranking done, we have to use analytics functions, and that's why I will say val top n daily products equal to daily product revenue dot, okay, with column. Now I will get rnk. Rnk is the variable name, and then rank, and then over, and then window dot spec, sorry, window dot partition by. The reason why it is not trying to autofill is because we haven't imported the package which belongs, which contains this window and window spec. So I can say, I can keep the cursor here, and actually it should prompt. It should prompt, and we can autofill. Okay, let me say function alt enter. Yeah, let me say import class, and we are talking about org.apache.spark.sql expressions. Okay, and now it is imported, and now I can say partition by, and I want to partition by order date, and then order by daily product revenue, as I want to sort it in descending order. Okay, as I want to sort in descending order, I have to specify as column, not as string, and hence I'm using dollar before daily product revenue, and then I can say DESC or .DESC. You can use either approach. Okay, now we got the rank, and I will give the field name as rank, and then I'll pass this rank here, which is variable name, and the new data frame will contain 4 fields. One is order date, second one is order item product ID, third one is order item subtotal, and fourth one is rank. Okay, now I can say top n daily products dot order by order date, and then rank. Also, I want to get only top 5, and hence I have to use where clause here. Okay, where rnk less than or equal to, let me define a variable top n. Okay, for now I will just hard code top n equal to 5. We will parameterize at a later point in time, but for now we will just hard code, and then dot, and then I just want to preview the data by saying show, save it, and now let me run it. Okay, there seems to be typo somewhere. So, okay, order items, it should be order items. Now it should be fine. So whenever you see error, you will see process finished with exit code 1, and then you have to scroll up in the stack to actually check the error. Last time it is complaining that the path users IT university research data retail DB JSON order capital items doesn't exist. As the path is incorrect, it has thrown that error. Now you see process finished with exit code 0, and you can see the results here, and we can see for each date data top 5 products by revenue. Now we cannot just build a jar file out of this and deploy in production, okay, because the paths which we have used for development might be significantly different from production. So after testing it, we cannot just update the path and then build the jar file, because again it can cause typos, and you might be pushing untested code, which is very risky. So either you have to pass this information such as input based directory, output based directory, top n, execution mode, all these things as properties to your program, external properties to your program, or you have to pass as runtime arguments. You should limit runtime arguments as much as possible, and you all the static information should be passed as externalized properties. Only those which might change on regular basis, you should pass it as runtime argument. For this program, if you want to test this with different top n, that means your value for top n might change periodically, and hence you might want to use this as runtime argument, where you pass in the command prompt while submitting the job. And rest of the stuff, such as input based directory, output based directory, master, all these things are static based upon the environment. So for production, you will have one master, one input based directory, one output directory. For testing, you will have different values. For development, you will have different values. So those things you should externalize rather than passing them as arguments, because if you pass everything as runtime argument, your command to submit the jobs will become cumbersome, and it might become unmanageable over a period of time. So you have to limit the number of arguments that needs to be passed at runtime in command prompt. Okay. So that being said, as we are using Scala as programming language, we have to use Scala-based plugins to process externalized properties. And one such plugin is type-safe config. So you can go to Google and search for Scala type-safe config. Almost all the programming languages have this. Okay, and you can get the main repository here. Okay, and you can see the explanation how to use these things, etc. And to first use as part of your program, as it is SBT based project, we have to copy this and add it to build.sbt. Only then the APIs are exposed for your program to use it to pass the properties. Okay, I add it and I saved it, and you can see that it is downloading certain binaries or dependencies from repositories. Okay, if you are familiar with Maven, this is group ID, this is artifact ID, and this is version. And even SBT might share the same Maven repositories for you to download and use as part of your program. It will only download the jar file based on this group ID, artifact ID, and then version. Okay, once you have this, to externalize the properties, there are multiple ways to do to externalize the properties. One standard way of doing it is you will have the properties file in exactly the same location in dev, testing, and production. Okay, so for example, let's say so what the way it will be handled is, as part of your development, production, as well as testing environment, you will, if it is Linux based environment, typically we use /etc and then / our application name, and we will get our application properties as configuration files in that location. Okay, that is one approach where you will have the files with the same path in all the 3 different environments, and all the properties names and values will follow the similar structure. The property names will be same in dev, test, and production, but the values will be environment specific. Okay, so for example, if you look at this get top and daily products df, there can be something like input.base.directory, and value in development could be this, and value for testing can be different, and value for production can be significantly different. But the properties file which contains this information will be in the same location in dev, test, and production. That is one approach. Second approach is, so in that approach, we will externalize the properties completely from our program. We don't bundle the properties along with our program. And the second approach is, we can actually bundle as part of the program. It all depends upon your project specific best practices which you follow. There is no preference one over the other. And the second approach, second highly standard approach is, as part of the code itself, under source main, typically we will create a directory with name resources. Okay, so you see source main resources. In this, we will create a properties file. Okay, and that properties file can contain properties in multiple standards. It can be key value pairs, it can be JSON, it can be YML if you are familiar with YAML file format, which is very popular with Ruby and Python. So depending upon programming language and the comfort level and best practices of the project, we define properties in different way. It can be simple key value pair where key and value are separated by spaces, or it can be XML, it can be JSON, or whatever standard format is. When it comes to type safe config, it supports multiple file formats, JSON, and then key value pairs. Those are the standards. And as long as you have file names like this, application.conf, application.json, application.properties, or reference.conf, we don't even need to give the path to load. Okay, there is an API which we have to invoke, and it will take care of loading the properties file from this location, source main resources, as long as the location is source main resources and the file name is one of these things. Okay, now as part of this application properties, we can define development specific properties, UAT specific properties, production specific properties. Okay, and as all the as the properties belonging to multiple environments are part of same properties file, we have to group them. All development ones can start with the dev dot. Okay, and let's say input base directory, and I think the syntax is equal to, I do not remember whether it is space or equal to. We will see. If it fails, then we will actually convert into space. For now, I will be using equal, and then users, diversity, research, data, retail, DB, JSON. This is my base directory in development. Similarly, for production, my location will be public, retail, DB, JSON. Also, my execution mode in dev.execution mode. In dev, I want to run in local, and in production, I want to, except for this category, remaining part should be same for each environment. So for UAT, you will have uat.execution.mode. For input-based directory, you will have uat.input.base directory. Okay, and you will understand the significance of it when we actually start loading these properties as part of our program. Equal to, in this case, I want to use yarn, I think, client. Okay, and then dev.output base directory equal to users itversity research data. Okay, and then prod.output.base directory equal to user training retail. This is my base directory for storing the output. Okay, now we got the properties defined for development and production. We have to get to the program. Okay, and then you can actually import com.typesafe.config factory. Okay, so using this config factory, we can load the properties as part of the program. So in this case, I am saying val props. So this will load all the properties from the file. Okay, so I just have to say config factory dot load, and we don't need to pass any argument as long as our path is source main resources within our source code, and the file name is application.properties or application.conf or application.json, etc. But if the path is different, the other approach which I have mentioned earlier, where the properties files might be in a standard location such as /etc/our application specific folder /config, and if the properties file is in that location, then we have to pass that path here. Okay, but in this case, we are bundling as part of the code, and hence we don't need to pass anything as long as the location is source main resources and the properties file is application.properties. Okay, now we got all the properties, and depending upon the environment, we have to read the appropriate values. So I am creating another variable called env props. Okay, and then props.get. So you can use APIs such as string, integer, etc., get integer, get string, etc., and pass this complete property name and get the value. Okay, so if it is a integer value, you have to use get integer, and it will be loading that value for you. But in this case, by using the group, I want to capture all the properties in that group. Okay, for that, if you look at the APIs, there is an API called get config. Okay, as part of the get config, we have to pass the group, which is nothing but the first part with the dot as delimiter. So this will be the group. Okay, now env props will contain all the properties related to dev. If I pass prod, it will contain all the properties related to prod. As it can change between environments, we have to pass it as argument. Okay, this part we have to pass it as argument. At runtime, based upon what we have passed, it will load the properties as part of your program. Now env props, if dev is passed, will contain execution mode, input base directory, trimming off the group. Okay, now to replace this hard-coded value with the property from the properties file, I have to say env props dot get string, because execution mode is defined as string. Okay, and then I have to say execution dot mode. It will give us the execution mode at runtime. Similarly, I want to get this top n also passed as runtime argument. So there will be two runtime arguments. One is the environment, and the second one is a token. Okay, so in this case, I will say args of 1 dot 2 int. Okay, and then as part of the app name also, I just want to give, or I just want to specify what we are using at runtime as part of the program name itself, and hence I am customizing this logic also. Okay, now the next one which we need to replace is input base directory. Okay, env props dot get string and then input dot base dot directory. Similarly, we want to get output base directory. Okay, val output base directory equal to env props dot get string output dot base dot dir, and we can say write dot JSON. So I want to save it in JSON format. Output base directory plus get top n daily products using df. Okay, just to I want to give some unique name, that's why I make it a bit complicated, otherwise we don't need to do this. Now we have to pass runtime arguments to run this program. So I have to go to run, edit configurations, and here the first argument is the environment in which we are running, and the second argument is number of top products which we get by revenue. So I can say apply, okay, and then now I can run this. As it run, I can go to the Explorer and let us see what whether we the directory with get top and daily products using df will be created here as it run. Watch out for the exit code. As long as it is 0, most likely it is successful. Otherwise, we have to troubleshoot based on the exception. Okay, so you can see here it is created already, get top and daily products. Okay, and then we can actually open with Sublime Text. And here we can see that for each day we got top 5 products. Okay, now we are done with the development life cycle. This is deployable in production after testing. What we have to do, we just have to copy this path, go to terminal, and then go to the directory. If you have spaces in your directory path, you just have to put it in double quotes, something like this. Okay, and then it will go to the directory, and then you have to say sbt package. It will build the jar file for you. Okay. As the jar file is built, now we can ship it to the cluster and we can run it on the cluster. You can see what all are there in this jar file by just copying and then running jar tvf command. This is very, very important command to troubleshoot the issues. Okay. Yeah, so for scheduling purposes, for deploying, we can use Jenkins. You can integrate with Jenkins and you can deploy. For scheduling, Woozy is fading out. Woozy is big data technology, but it is fading out, and it is being replaced by LinkedIn's Azkaban and Airbnb's Airflow. So these are the workflow and scheduling tools that are becoming open source standards in big data world. So you have to explore those things. For deployment, you can use Jenkins or whatever industry standard tools you have. Okay, you just need to understand how to integrate those things. Sometimes you might have to write shell scripts to integrate. Okay, now that being said, you can see this has only classes related to the programs which we have developed. It doesn't have anything related to type-safe config or Spark. Okay, but as we have Spark on the cluster already, for Spark binaries, it will work without any issues when we run on the cluster. But com.typesafe config is not part of Spark, and hence we have to tell where the typesafe config jar file is at runtime. So let me run it and you will understand. Okay, so now I am FCPing this to the lab, gateway node of the lab. Okay, where we have a 10 node cluster. Consider that as a production, and then log into that. Make sure the jar file is copied. You can see here. You can use Spark submit, but we are using Spark 2.3. We have compiled our project with Spark 2.3, and we have both Spark 1.6 and Spark 2 on the lab. And hence, if I try to run by default, it uses Spark 1.6 and it will fail. Okay. For that reason, we have to export a variable called Spark _ major _ version equal to 2, and then you can use Spark submit. Okay, and Spark submit, I will start with master yarn, and then I will say deploy mode. Because I am running in yarn mode, I have to say deploy mode, and I want to run it in client mode. Okay, and then the class name is, I have to get the fully qualified class name, which is nothing but retail db dot get top end daily products df. Okay, and then as this is multi-tenant environment, in my lab you have to use this spark.ui.port equal to some 5-digit number, in this case 12890, and then I can say the jar file name tetrademo _ 2.11 -1.0.jar, and it takes 2 arguments. In this case I want to run in prod mode, and then the second argument is the number of products which I want to get, and hit enter. Now you see it is complaining on com typesafe config factory, and this jar file only have the compiled source code of ours. It doesn't have any Spark related stuff, but it will not fail on Spark related stuff because Spark is already deployed on all the nodes in the cluster in this location. User HDP Spark 2 point blah blah blah, and then Spark 2, and then I think it is under jars. You see, all these jar files are available for you at runtime. It doesn't include typesafe config. So to fix this issue, either you have to copy typesafe config on all the nodes into this location, or you have to register at runtime. So now I can go back to this Spark submit code and then specify the typesafe config either by using packages. If you use packages, it will download at runtime from the internet. So it is not a good practice to use packages except for troubleshooting purposes. But in this case, I will be using both packages, and also I will tell you how to use jar files also. So with respect to packages, you just have to say group ID colon artifact ID, which is nothing but config, and then version, which is nothing but 1.3.2. And if I run it, it will work. On top of this thing, if you know the location of the jar file in the local machine, you can give jars like this. You can specify jars, and you have to give fully qualified path name of the jar. So you need to know the fully qualified path name. For example, if it is in this location, okay, which is nothing but user HDP 2.5 blah 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 Spark 2 jars. and then you have to give slash, and you have to give the jar file name. You have to give fully qualified path name of the jar, or fully qualified name of the jar file. So in this case, for simplicity purpose, I am using packages because I remember this than the path I have locally also, but I don't remember on top of my head, and hence I'm using packages. com.typesafe config 1.3.2 and hit enter. Now you can see that it has downloaded the jar file for you, and it will actually run the job and process the data for you, and the output will be saved to the location which we have specified. It will just take a moment. Okay, now it is done. And let us take the output path from application.properties, which is nothing but user training retail, Hadoop FS -ls, user training retail, and then the program name is, sorry, the directory name is get top and daily products using df, and then hit enter. You can see the JSON files here. Now you can say Hadoop FS -tail, and then give the path, and you can preview the last 1 KB of data. Okay, you can see for 2014 February 1st, there are 5 products. The first one generated $11,999 in revenue, then $8,158, then $7,799, so on and so forth. Okay, this is how you can go through the development lifecycle and execution lifecycle, deployment lifecycle of your application. That being said, there is one missing part in last 3 sessions, which I could not execute. That is a very important expression called case when. So I will cover that also, and we will wrap up for today. I'm launching Spark Shell here. Okay, and here I can say val input base directory equal to this one, and then let me go to top and daily products and copy the code related to orders to read the orders data. And then you can say orders.show to preview the data. Now let us say that I want to categorize closed and complete orders as completed, pending payment, processing payment review as pending, and all others as others. Okay, so I can use case when expression for that. So either you have to use expr. So let us take orders dot with column. I want to get all the other fields, and then the new field with column, status category. Let's say this is the field name. Okay, and then as part of expression, I can say case when order status in complete, comma, closed, then completed. Okay. For now, I will only give else, and I will improvise on that later. Else other. Okay. And the reason why it failed earlier is I forgot end. That's the only thing I forgot, and that was causing the issue, and I could not troubleshoot because of the time constraint. Now let us start with this and then say show. Okay, I think there is one more bracket which I have to specify. Yeah, this is for expression and this is for with column, and then dot show. Now you see the status category has completed for complete and closed. For others, it has given others. As I have demonstrated earlier, we can actually create a variable like this, val status category equal to expression, okay, and then case when, whatever logic we have developed here, okay, and then I can just say plus, and then when I'm making it a bit readable, when order status, so I have to put it in double quotes, when order status in pending payment processing payment preview. In those cases, I want to say pending, okay, else I just want to say other and end, okay, and then closing the expression and hit enter, okay. Now I can actually go back to here as part of the with column. I can just give the column name, which is nothing but status category, sorry, variable name, which is nothing but status category, and I can say show. Okay, now using these new categories, if I want to get the count, what I can do, I can say dot group by status category dot count and hit enter, and then dot show. Okay, so it will actually say how many are in completed, how many are in pending, and how many in other state. Like this, you can develop advanced expressions using EXPR function. And as part of EXPR, you can give any valid SQL expressions like this. On top of this EXPR, there is also select EXPR. Okay, and if you just want to apply logic on one field, and if you want to get the data only for that one field, you can say select EXPR like this, and then you can actually pass either variable name or expression in the form of string, and then you can get the select XPR has to be of type string type. So I need to go back here. So if I want to use select XPR, I should not use EXPR function. If I use EXPR function, it will not work. So I just have to remove this EXPR. Select plus EXPR is nothing but select EXPR. As EXPR is included in this, we should not pass a column derived from EXPR. Okay, and it has to be of type string. Okay, now I think I have to use triple quote like that, and then okay, now we got the string. Now I can actually use select XPR status category and then dot show. Okay, if you want to give alias to it, I think you can give alias like this. No, you cannot give alias like this. So if you have to give alias, you have to select once again. Okay, and then you have to say something like this: status category dot alias status category. Okay, now it will work. Okay, there is some issue with this. Okay. I cannot use this. So I don't know how to give alias. Yeah, only thing think I think with this approach it is not straightforward if I use select expression, or there could be some way. I'm not sure. Okay, so these are the important APIs which you need to be familiar with. So if you look at the data frame name, we have covered multiple APIs such as filter or where to filter the data. We have covered a print schema to print the schema, show to look at the preview of the data. Okay, we have seen order by to sort the data. We have seen group by to perform grouping operations. And as part of all these things, we also explored several functions which are exposed from the package called org.apache.spark.sql.functions. We have gone through analytics functions also. On top of those things, I have also covered some of the important APIs such as drop, to drop a particular field from a data frame while creating the new data frame, and so on and so forth. There are certain things which I haven't covered, which you should be able to explore whenever it is required. So for example, I haven't covered union. Union operations are not that important compared to the others which I have covered, and it's pretty straightforward, and hence I'm not going to cover. And then transform is more of a machine learning related API, and hence I do not cover that. Okay, so that's about the data frame operations. Very important. Once you build basics of data frames and operations on top of it, you can actually understand machine learning libraries and all those things at a later point in time very easily. On top of all those things, we also have gone through write. Write is the package which will expose us to write our data in multiple file formats, or even into remote databases using JDBC, or we can also write into Hive tables using insert into save as table, etc. And these APIs I will be covering as part of the next session, where I'll be talking about Spark SQL and also integration with Hive, etc. If you have any questions, let me know. Otherwise, we will wrap up for today. Once again, I will give 15 seconds. Kaushik confirmed that it should work for you to access the course in Kaizen. Those who are on Zoom session, please confirm as part of the WhatsApp group if you could not access that. Okay. That being said, thank you. Bye. Those who are on YouTube, thank you very much for joining the session. It's my pleasure to share the knowledge. If you like the content of the video, please click on the like button. If you want to share with your friends, you can click on share, and you can share with your friends. And you can sign up for the lab to practice the way I have demonstrated. Once you develop the logic, if you want to deploy in production and test your code as if it is deployed in production, probably having lab access will help you. So you can sign up for the lab. It's very economical and very effective. And also we support in case if there are any issues. Not only we, but the community is there to support you. So sign up for the lab, leverage the forums, and we can take it from there. If you haven't subscribed to our channel yet, please do so that you can get notifications for our future sessions like this. Thank you. Bye.